I'm Steffen. I'm the co-founder of Utoolity. We are an add-on vendor in the marketplace, in the Atlassian marketplace, just like META-INF. We are not an Atlassian expert though. And we focus on integrating Amazon Web Services with AWS, with the Atlassian tools, sorry. And this is the AWS Management Console. Let me see a short show of hands, please. Who knows about Amazon Web Services? All right. Who is actually using it already? Just a few. Is there any other cloud provider in use, like Microsoft Azure or something? So that's pretty new to you in all around. So I'm just briefly, this is kind of the management console for the Amazon Web Services. Amazon Web Services has been a pioneer in the infrastructure as a service market. They kind of invented that in 2006, and this has been a very successful concept. It basically goes about offering infrastructure as a service. So you don't need to go into a shop and buy a physical hardware server, but instead you really can just use an API and order a computer, a system, various kinds of services, databases, and so on demand for a couple of hours. And this is very inexpensive and very, very fast. Being fast and flexible is actually the most important goal. It's not necessarily about the price. You can save a lot of money with this, but this requires a little bit of expertise. In general, it's really about being flexible. You all know about the Atlassian tools. I don't need to tell you about that. And this is us in the marketplace. We currently have 3 add-ons there. The first one is Identity Federation for AWS. It's available for Bamboo and for Jira. And this provides single sign-on with AWS. So the console you just saw in the previous slides, with these tools you can enable your Atlassian users, your groups, to simply click on a menu and they can then log into they get automatically logged into the Amazon console and can use these services. So this is kind of an administration help, especially. And our main product is at the bottom. That's Tasks for AWS for Bamboo. And this this offers various tasks for Bamboo to allow you to actually deploy your software to Amazon Web Services in a simple and straightforward way. We support in a way we support all services, but there are only specific tasks for a couple of them, notably the deployment-oriented services. All right, let's get started. What are we going to talk about? I just want to briefly get a shared understanding what continuous delivery and integration are. Then we're going to look at why we actually want to do that today, and we also will look at how to get started with this, because that's usually the most important thing. So everything comes together in what's nowadays usually called the pipeline. The pipeline is about continuous integration, delivery, and deployment. And we talk about each of these steps in detail in a minute. But first, let me see another show of hands, please. Who remembers the Joel test? Nobody but me. That's amazing. I'm so old. So that's actually hard to talk about that. Then I'll just go through it briefly. The Joel test has been called 12 Steps to Better Code. Has been written by Joel Spolsky 16 years ago. And Joel Spolsky has been an entrepreneur. He's been at the Microsoft Excel team, and I think he kind of has written VBA. But he is most known nowadays for being the co-founder of Stack Overflow together with Jeff Atwood. I hope Stack Overflow is known to a couple of you, to the developers mostly. I can certainly not live without it. It's really the most important resource for software development in the internet today, to me at least. Joel also runs a company that's called Fog Creek, and they built Trello, which is a software as a service agile board offering. in a way it's similar to Jira Agile, but we're just focused on the board. So the Joel test, first question was, back then, 16 years ago, do you use source control? I mean, nowadays it's probably a given, everybody does this, right? But at that time, you actually had to ask this because it wasn't really commonplace, and people had to become educated about actually using source control. Second question was, can you make a build in one step? That's also sort of intuitive, but if you really think about it, do you really build all your stuff in one step? That's what you meant. Can you really release your software? Can you build your software? It's just about the build at that point. Can you build your software in a single step at the press of a button? And the third question has been, do you make daily builds? Now, to me, this already sounds a little bit funny from nowadays perspective because of all the tooling advances, things have become much easier, much faster, and it's quite common to use tools like Bitbucket from Atlassian or GitHub to have a shared version control and arrange things in a way that you can that every commit or every push is actually getting built already. So daily is kind of slow from that angle, but at that point this was important because builds were expensive. So it took a long time eventually, and so people tended to not do it. The other questions are actually not relevant here. I just wanted to point that out because these three steps are the pillar of continuous integration. He didn't call it like that, but basically this is it. The phrase continuous integration is a little bit older, but it always takes a little bit of time until the software community gets a shared understanding what such a phrase is about. And this is now kind of a done deal. This is how Martin Fowler defines continuous integration. Martin Fowler is a software architect and works at ThoughtWorks. He's a well-known public author and speaker and has written quite some important articles. This is kind of the landmark from the landmark article about continuous integration. And you see the three previous steps are kind of in there. It's a little bit convoluted, but the key points are that each person, each team member really integrates at least daily. So they push their code into the main line of the software project. And this is verified by an automated build, including the tests, so that integration errors are detected early. I kind of think that this is something that most people are meanwhile familiar with one way or the other, so it's quite common. So most teams I work with actually are in various ways and levels of expertise familiar with this and do it one way or the other. So, sorry. So what are the main ingredients? This is about the build pipeline. So it's about building the software you want to ship out. You build either for desktop some binary, or you build mostly these days some software as a service that you want to deploy for public usage. And this is comprised of three main activities. You commit new code. That's what you and your team have been building anew. And you push that up to the shared repository, typically a distributed version control like Git these days. But it also works with others conceptually. Once it's pushed up, it needs to be integrated with the code that's already there. So it kind of needs to be merged together. So this is where all the teamwork comes together. And this is a kind of a delicate step, but these days it's easier. Git is very powerful in these ways and helps a lot in dealing with this. But because this activity is kind of critical, it needs to be done very often to reduce the risks there. Get to that later a little bit more. Once the code is integrated, it needs to be built to actually verify that everything works as expected, to create the software in the first place, and get the package that you actually can, in theory, can deploy to your systems. So, no, I'm not going to talk about that. So, before I switch to continuous delivery, this is another one that I hope a couple of more people are known, the Agile Manifesto. Who knows that? All right, that's better, so that works better. It's also a software concept. It's not as old. It has been written by 17 authors 15 years ago. Also 12 principles. 12 seems to be the lucky number there. And this has been various experts in the field of software development who have practiced agile software development for quite a while already. And they kind of gather together to get this shared understanding, to actually say, we want to define how this works so that we can really move the industry forward in a collaborative way. And to all of you who already know that, the question is actually, do you really know it by heart? I have been quite surprised when I read it again, because the first principle reads, our highest priority is to satisfy the customers through early and continuous delivery of valuable software. So there you have it, it's right there. It's 15 years ago, it's a very long time, and they already defined continuous delivery, so it should be a done deal by now. The question is, why are we talking about it so today? The second one is not really relevant, it's just reaffirming what it's about. But the third principle reveals why we are talking about it today. They say, deliver working software frequently, from a couple of weeks to a couple of months, with a preference to the shorter time scale. Now, this is probably pretty straightforward. This is the reason why we are here, to talk about the importance of continuous delivery now, because clearly visible there, 15 years ago, even a couple of months have been seen as a positive thing. It was already an advantage over these 3-year-long delivery cycles. But as everybody probably experienced in his or her own daily work, this is not what's required from you today. In today's business, you need to be much faster than that. A couple of weeks might be completely reasonable for many projects. In other projects, you really need to generate results daily. Doesn't mean that you really need to ship this out to your customers, but at least for your entire process, it's important that you get quick results. And this is now possible due to advances in the industry, due to cloud computing and other technologies which really help to speed things up. And the other ones are not relevant here, though. And this is once again Martin Fowler, this time just 3 years ago. So you can see how this always takes a while until such things get a snappy definition everyone agrees on. Continuous delivery is a software development discipline where you build software in such a way that the software can be released to production at any time. And any time is really what this is about. He means this literally. He wants that software is created in a way that you can push a button when you want to, when you need to, and you get a new build of your entire product, so that you can ship out features, new features, or bug fixes, or for whatever reason, on demand whenever you want to. This is key to this, and we're going to look at this a little bit more. So what does this mean? This is in contrast to the build pipeline which we had before with continuous integration. Continuous delivery is about the deployment pipeline. So in continuous integration goes to the point where you have created your software package. Think of it like a binary or a service that you want to deploy. But you haven't actually deployed it, because deployment, as we all know, is a very complex process eventually. There are lots of things involved, lots of things can go wrong, and that's why often many steps are manual. And continuous delivery is about removing those manual steps and creating a deployment pipeline that does exactly that. The first step actually is to deploy the artifact into a production-like environment. So you actually you want to perform the step that you would do if you really would release the software to your customers. And production-like is kind of the ultimate goal, but it's meant like within the bounds of reason. So if you can do it, there are quite some scenarios where this is possible. It's a good idea to really have a clone of your production environment, or there are some techniques to actually use the production environment but deploy different versions of your software into this very same environment and just show one to the customers at any time. With this deployed artifact in place in the production-like environment, you want to verify the artifact. And once again, you do production-oriented tests. This means you really simulate the production workload. You run acceptance tests that check whether your software is performing for a large amount of users eventually. You run security tests to really see if this is open in the internet, that there are no security holes. You also run load tests to really see whether you can scale this up and so on. So once this is approved and you have approved that the software is working as expected, you actually deliver the artifact so that you get this push button deployed to production. So this means, as Martin Fowler said, you want to enable your entire team, your business, your manager, and yourself to really deploy any version that you have, the current one, the next one you plan to deliver, to any environment you might have around, some test environment, some others, or the real production environment, at the push of a button. This is about making this a business decision. So it should always be possible for the management to say, please ship the software tomorrow. And the current state that is tested should be just available for shipping out to the customers at the push of a button. So in summary, this is about automating not the generation of the software that you're going to ship, but the deployment. This is something that's not always done correctly and available in a readily available fashion. Going to talk about it in a moment. So if continuous delivery is already about deployment, the terms are a little bit confusing, right? What is continuous deployment then? So continuous deployment is continuous delivery unleashed. That's about it. Okay, I just made this up, but let's look at somebody more professional. This is Jay Samuel. He is the expert on continuous delivery. He wrote the book on it. It's actually called Continuous Delivery. It's a very good book. It's quite recent still and still completely current in a way. Continuous deployment is a practice of releasing every good build to users. A more accurate name might have been continuous release. He himself coined it, kind of made continuous delivery popular, and he should have. It would have been great if he would have used this continuous release, because it would be so much easier to talk about these things if you had 3 different acronyms, not just 2. CI, CD, CD doesn't really work, but CI, CD, CR is quite fine. So, to put it another way, continuous deployment is the deployment pipeline we already looked at for the continuous delivery phase without the button. And so this is how it looks like. That's really about it. So on the top, you see a pipeline that deploys code from left to right, and the ultimate goal is to deploy the code to production. But before you do that, you have a manual step where you really want to enable people to make a decision. And continuous deployment is the very same pipeline. There's nothing different except that you remove this button. That's really about it. There's nothing special. And this is just conceptualized, of course. The first 3 are kind of the integration phase. The 4th one is the delivery phase. That's a bit short. There is usually more to it, but the acceptance test covers this nicely. And finally, you really deploy the code to the servers, and you want to have this running on. And as I just emphasized already, the distinction here is really just whether you make this decision, whether you want to have this decision under your control, or whether you want to just get every good build out to the users, as Samuel just said. Now, if you think about this, this doesn't have to be an exclusive decision. For example, you might, once you have the continuous delivery pipeline in place, and this works from a technical point of view, you could decide to deliver your code to your end users every, say, 4 weeks, or and this is a manual decision then, because it might probably doesn't make sense to really release something to your end users every day. They get confused. You might need to educate them before you can roll out something into the company. But it might be a good idea to do just flip this and say, regardless, I will continuously deploy the code, the software we are producing to our own servers for our own team internally in-house, so that we are dogfooding our own product. This is something Atlassian is very famously doing, and it's highly recommended. So, why do we want to do this now? Why is continuous delivery such a topic at the moment? Well, this is about speed, first and foremost. And also, it's about speed. And you guessed it, finally, it's about speed. But I should probably be a little bit more specific here. So it's about the business case. And the most important reason is to get early and frequent user feedback. Many have experienced this already. You're building a product over a couple of times. It lasts 3 months and two months longer than you actually planned to. And once it is rolled out, it's probably outdated. Or the users, you get the feedback from the users that you didn't really capture their intent. And another problem that's quite common is that software development teams over time develop a very biased understanding of the problem domain they are developing for. So you have a good team, you might be very experienced with what you're doing, let's say finances or so, but still you are not actually running the business that is using your software. And this business is evolving all the time, and so you need to adapt to this. And from that angle, it's really a good idea to get early and frequent feedback. And this is most easily achieved by having small releases, early, often, fast. So don't wait for 3 months, 6 months, or even a year until you deliver the product. Try to ship small features, maybe even test candidates, so that you can get feedback on whether you're building the right thing. The second topic is reduce deployment risk. Now, this might seem counterintuitive. If deployment is perceived as a risk, and it is, at least for me still, why is doing it more often improving this? This is because of 2 things. As I just briefly mentioned before already, the most important aspect of this is that you are reducing the scope of the deployment. When you release a new version only every other year, there are probably lots of changes going into your software. And when something goes wrong, for example, and you have maybe not captured in some edge case, or you get a regression due to different production environments than expected, it's very, very hard to find this problem in this huge amount of code that you have shipped, possibly comprised from different teams, various persons involved, maybe in different time zones, and it's very, very hard to see through this is literally looking for the needle in the haystack at a time. In contrast, if you think about if you would be able to really ship each and every feature by its own, just a single feature, then you immediately have the situation, if something goes wrong with this, you know who to talk to, you know the team who is responsible, and even for the team, it's very simple to look after that, because they just have a single feature shipped, they have a couple of commits that comprise this feature, and they probably have a much easier time to actually identify the problem And you can then go forward because you have mastered continuous delivery already. You can either fix the bug very quickly and just deploy the next best release and the next fixed release, or maybe you have previously rolled back because that's also an easy process once you have continuous delivery. And in turn, this is about increased confidence and trust. This continuous delivery is a journey about improving your delivery process, the way you actually can create and ship software, so that you become more relaxed about that. Humans are very good humans get very good when they repeat things very often. So you get better at that when you do it a lot of times. So this is also reducing the risk. And also humans get easily bored if they have to do things identically all the time. And so it's quite kind of a feedback loop. Once you have a little bit of this in place, your team will be motivated to further remove the steps that are painful or take a long time or are otherwise undesired. And this is not just for your internal team, for your colleagues, for your development team, it's also for the management. The management sometimes there is kind of a tension between management and developers. Please ship this at this particular date, you need to do it, or we have a bug fix, we have a new customer, can I get this feature fast, and all this stuff. And you get a lot of pressure between these two stakeholders going on. And once a continuous delivery pipeline is there, even the management gets more relaxed because they know they can actually get their stuff when they want to. They don't need to pressure the team to work faster or harder. This is really a collaborative process. You basically want to make deployment a non-event. It should not be that thing that everybody's afraid of. So, how do we do it? So, this is about automation, basically. It's also about automation, and yeah, it's really about automation. That's everything about it. And more specifically, it's about the deployment pipeline we mentioned already, and you need to, in the end, you need to automate all parts of the delivery process. And that's, unfortunately, that's meant literally. You really need to automate all parts down the road. That's the ultimate goal. However, as daunting as this sounds, this is not a reason to hold off on starting your journey into continuous delivery, because every single step that you do in this direction helps a lot already. It already removes something that has been manual, it speeds something up eventually, and will be beneficial and generate this confidence in your ability to deliver software. In order to do this, you need to versionize all aspects of software and environments. And I would really ask you to shortly think about it. Everybody is using version control, I assume, for the software they are building themselves. However, if you think about it hard, do you really versionize all aspects of your entire software delivery process? There are lots of more things involved in this. First and foremost, the environments. So the servers where you deploy the software to, if it's a software as a service. Or the test environments where you test your desktop software in. All these things need to be available in a controlled and repeatable fashion if you want to do continuous delivery. So you need to start versionizing all of them and making them all automated. Another aspect that's often not in sync is documentation, for example. Good software should come with at least some documentation, and we are all too familiar with that documentation goes out of sync with the release. I mean, this might just be because nobody actually updates the software, but quite sometimes it's also because those two things are not connected. Somebody writes some documents somewhere else, or possibly in a wiki with Confluence. That's actually a problem when you want to do this. And on the other hand, you release the software, and these two things need to go together somehow. There are ways to work with this, so you can definitely use, and I do this myself, use Confluence for documenting software. But it's a tricky thing to really ensure that when you push out a new release, you get a get a correlated set of documentation deployed to the end users as well. And this is probably obvious. In order to achieve these two topics, you need to really collaborate closely with everyone involved. Because releasing software to end users is a process that usually involves lots of stakeholders. So it's not just about the developers. It's probably about the operations team if it's a software as a service. It's about the management who make decisions about this. It's about documentation, quality control, possibly some legal aspects. And if it's vitally important that everybody buys into continuous delivery. Otherwise, you will not achieve your ultimate goal. In other words, it's a kind of what's nowadays been talked a lot about, this DevOps culture. So it's about removing the boundaries between the various teams in your organization and really come together as a team that delivers a specific project. This is also why in very successful organizations these days, the team behind a specific software product is very often called a cross-functional team. So they have various capabilities within one team, and so that it's easier to actually build a product without all this bureaucratic overhead. So I already mentioned that this seems daunting. So this is about automation coverage, sort of like test coverage. And you might ask yourself, is it worth the time? If I need to automate every step, that's a lot of time, right? And there's a very famous XKCD about that. I really like that one. It's about the question whether it's worth your time to automate a particular step that takes a little bit of time, so that you not in the end spend more time automating it rather than you win. However, I have to tell you, this does not apply to CI/CD, because CI/CD is not about speed. It's not about winning the time alone. It's also about the different other things I just talked about. It's about gaining trust in your process, removing this freak out situations. Oh God, I need to make a release. This is really not something you want. It's about the ability to do this on demand, so that there's no stress factor and so on. And so for the ultimate goal of continuous delivery, you actually need to ignore this chart and automate every step, no matter how small or how big. However, I want to emphasize again, this is not a reason to hold off on this. Every step has already, so you should just get started. And how I would recommend to doing this, it's absolutely the right thing to do in my mind to explore this with a fun project. So don't go home and try to do this with your current important production software. Rather, take a very, very, very small thing that you always wanted to do, or just a sample open source project, and try to implement a CI/CD pipeline with the tooling you already use. And being at Atlassian Day here in Budapest, I assume we all use Atlassian tools, so it would be Atlassian. Atlassian has an opinionated workflow around this, so they support this in their very own way, so it makes a lot of sense and makes things easier if you try to follow their lead and apply the techniques Atlassian sort of prescribes. It's not a requirement. You can, of course, do your own thing. That's a good thing about Atlassian. Everything is customizable. But to get started, it's probably easiest to just follow the lead. Now, that's the fun part. And now I have to say this is really unfortunate. This is a kind of painful part. You need to go and need to document your current release process from your current project. And depending on the size of the project, this can be tiresome. Because it really means capturing every single detail of your deployment process. There should not be a single manual step, no matter how small, that isn't automated in the end. And in order to identify those, you need to write it down. I guess you might already have this, sort of a run book, how to do a release, what do you need to do, some checklist kind of thing. But it's probably not detailed enough. If you think about it hard, you will probably find some steps where the knowledge is just in the head of the person who does this. And this is kind of an assessment that needs to be done. Once this is done, you can really pick any step and start automating. It doesn't matter which kind of step. You can pick the simplest one to get started with this project. You can also say, if your team is just in the mood and you say, okay, we have this very painful one, let's tackle that one, then you can start with a more complex one. And this really doesn't matter. And I also will be honest with you, there are things that are really highly complex. So the message I want to get across is, it's very the concepts we are talking about are very, very simple. And it's easy to get started. However, getting to the ultimate goal of having a continuous delivery pipeline that really works well can be complex depending on the part of the kind of software you're building. For example, in almost no presentation anybody ever talks about how to migrate databases in continuous delivery scenarios, because that's really, really complex. But it's a solved problem. It's possible. You can do that. It just requires more work. And it still comes with the very same benefits. Once you have invested this work at some point, you can move much faster. I have to try to check how I'm with the time because we started a little late. Sorry for that. Okay, so yeah, I think I can move on to a couple of trends that help you with this. So what are some related trends that in recent times that help achieve these goals? They are not necessarily tied to this, but they help a lot. The first one is infrastructure as code. This is something I briefly mentioned at the beginning of my talk when describing what Amazon Web Services is about. And this means that you gain the ability. These days we have the ability to spin up servers for our use, even very powerful ones, with a kind of a deployment manifest, with an instruction that's kind of like code. It's a configuration document, and this can be versionized just like your software. And like this, you can track. You can spin up infrastructure in a very fast way. You can track the environments in a precise way. So you always know exactly how your environments are comprised, and you can repeat this all the time in various places over the world. Of course, this is most easily done with cloud computing, so this is sort of the backing for this trend, but it's not necessarily tied to this. You can, of course, also apply similar principles, at least in parts, with physical servers. It's more like configuration as code in this case, so that you, of course, you cannot get the actual server automated, but you can automate the complete operating system and everything like that with tools like Puppet and Chef and so on. This is something that's absolutely vital and very liberating once you have started to do that, because everything gets repeatable and it's easy for each and every team to just start their own environments on demand. Another recent trend is containerization, or otherwise known as Docker. It's the usual term. Containerization in itself is also very old, but it has been made available to the masses, sort of thing, by means of Docker. The Docker toolset is very powerful and has made this easy to use. And if you are still in the business of actually running software on servers, on physical servers, I would encourage you to look into this, look into Docker, because this is kind of the bridge between the two things. Inside a container is still a simulated physical hardware, so it's basically from the point of view of the software, it's the same thing. But once you have containerized your application, you are able to move it around. So your software still thinks it's running in a physical server sort of thing, but you can deploy it in the cloud or on an actual physical server and gain a lot of flexibility there. And this is kind of about, that's called dev-prod parity. So you get the exact, it's easy for the developer to use the exact same technology that's then used in production by the operating team. Another trend you might come across these days is microservices. Now, as the phrase micro suggests, that seems to be a good thing given everything I talked about before. If things get smaller, they get simpler, right? That's what you think. And in a way, that's true. A microservice is just what's meant with that is it's a service that it's condensed to a very simple use case. So it's just implementing one feature, basically. Let's put it that way. And given that, it's a bounded context. It's easy to reason about. It's easy to develop. It's easy to continuously deploy because you have just one thing. And that's something that many teams are looking into to get more agility in the software development process. However, that comes with a drawback. That should not go unmentioned. Once you start using microservices, you suddenly get a different kind of problems, because if you previously have built maybe a single Java web application and deployed in a Tomcat container, you have a monolith, and you have certain constraints on this that are easy to handle, and because everything runs in one process. If you split this up into microservices, you get a completely different kind of failure scenarios. You suddenly need to work across the network. You need something that's called service discovery, because all these things need to work together and they need to talk to each other, and for that they need to have a way to find each other in the first place. And the guy I quoted 2 times, Martin Fowler, actually has a phrase, I forgot to put the picture in, I'm sorry, but he has a phrase to say, you need to be this tall to use microservices. And what he means is, you need to be an experienced team to actually do this. I partially agree with this, so it's a good sound warning. I think it shouldn't discourage you from looking into this for a new project, but it's probably not smart to go out and say, oh, this sounds very interesting, and I'm now going to split my current application up into lots of different parts, and everything will be great. That's just too complex. But for new projects, it's a good idea to look into this because it runs well with containerization and infrastructure as code. So it's a good match for these new abilities that the cloud provides, for example. And the most recent thing that's really just hot off the press last year or something is serverless architectures. This is bringing these kind of things to the extremes. It builds on these 3 previous ones, and it's making things even smaller. What's meant with this is, this has been pioneered, not in a strict sense, but in a public sense, pioneered by Amazon Web Services again, with a service that's called AWS Lambda. And this means you just have a single function that runs in the cloud. And you should really think about it, it's just one function like you would have in a Java or C++ program. And this single function is deployed as a single unit into the cloud. And this is made possible by containerization, because each such function is in fact running in a container. And this has quite some benefits, because this yields a completely managed service then. So you don't need to worry about operations anymore. This is all handled by your cloud provider. This is meanwhile available by all other cloud providers as well, in one way or the other. This single function spins up in a couple of milliseconds, literally, and only lives for a couple of milliseconds, because when the function ends, the container is getting destroyed, and you can move on. And this is highly beneficial because it isolates failure scenarios. If one out of a million goes wrong, it doesn't matter. You can scale out automatically. This is handled by your cloud provider then, and you don't need to care about this. Some call this, in a way, you could think about it as a nano service. It's even smaller than a microservice. A microservice is like a complete component, at least, with a complete software inside, whereas a serverless function is really just a single function in the cloud. Of course, it's also bringing these problems that I just mentioned for microservice to the extreme. So building an actual application out of that is something that's just currently explored by the software community. This is not a solved problem. It works, but there are lots of efforts to get some frameworks around this and so on. However, it's something really, really cool. If you want to play with something, I highly encourage you to look at that because you can use it for all sorts of automation. That's the most important thing. Each such function is a very good platform for automating a single step of whatever you want to automate, no matter whether it's in your software itself, in the delivery pipeline, or even on your desktop. You could just call out in such a function and do things there. It's quite fun. So, to recap, or let me briefly mention our promotion, please. You should have received this flyer, and you can get the one add-on we have. You can get completely for free. This, if you want to start with AWS, you can have this single sign-on to the management console. And if you want to have a discount for the other add-on, which enables all these things in Bamboo, please talk to me or send us an email, and we'll happily send you a code as well. The other code is printed right on the thing, so you can just go and use it. Okay, to recap, what is continuous delivery? It's about deploying any version to any environment at any time. This is the ultimate goal, but every step helps. So why do you want to do it? Frequent feedback, reduce risk, and increase confidence. Or from a business perspective, you want to build the right thing, fast and reliable. You want to build the software that your users actually want. And how do you do that? You need to automate all the things. As a team, one step at a time. Thank you.